We're filming.
So for everybody who is using this video, who do we thank?
Spencer.
Spencer. Don't talk with your mouth full. Okay. First thing you want to do for this lab is, and I mentioned it to everybody here already, but I'll just repeat it, and that is you all are using the exact same data, so you all are welcome to work together and come up with the exact same answer. But everybody, if you're doing it in Excel, has your own individually tailored spreadsheet and your own individual words for explaining how things happen. So, no plagiarism, but you are welcome to work together. So, for deriving the incline equation, recall that GM is equal to WD over delta tan theta. And in class, I explained how that equation came about with some trigonometry, and I won't do that again. But that's what I'd like you to do. Robert?
Can I just add that it's only valid for small angles less than 10 degrees?
Yes, and that would be a good thing, good point. Only valid for 10 degrees. Coast Guard says it's only valid to 4 degrees for the actual experiment. Section B is determine your displacement from your mean draft. So all of you recorded your draft forward and your draft aft. That gives you your mean draft. And then from there you get your displacement from SPE. And you also get your KM from SPE. What KM? Make sure you're reading KM sub T. Transverse, because SPE will give you KM sub L, which we don't really know about yet.
Yeah, that's average.
And then, as described in the ASTM, make your graph of WD versus WD versus tan theta, and you're going to plot your 8 data points and draw a straight line. I think it's best done in Excel. And let's see, would it be worthwhile, Alex, you're beautifully working over there. At some point, I think it would be worthwhile to record you showing how in Excel to get a straight line out of a bunch of dots.
Okay.
And also Excel will read you the slope.
Mm-hmm.
It'll give you the equation for the straight line.
Yeah, and the R squared.
Yeah, so if you'll show that later. All right, Spencer?
Yeah, I heard that.
Okay. So that will give you the slope, as I said before, will lead you to, but not directly, you'll get GM. And then in the handout you'll see determine kg without the incline weight, which I already went over in class, and there's the equation that you use. Step delta has you compare Km sub t based on, you'll notice if you flip to table 1 in your handout, table 1 gives you Kb and it gives you Bm. And those two added together is Km sub t. So you have Km sub t from handout table 1, and you also have Km sub t from SPE. I'd like you to compare the two. Who understands what I'm asking for, where you can get the first Km? One person does, 2 people do?
From the table 1, right?
Good. Any questions? Good. Then, let's see, what's the last requirement? Determine the moment to heal 1 degree. What in the world is that? If you have a ship, or that model that we just did the experiment on, you take a weight and you move it a certain distance, and you have a moment. It's going to cause the vessel to heel over 1 degree. What I would like to know is, what is the moment that will cause a 1 degree angle of lift? It's called MH1. And you can figure that out by this equation here. I'm going to rearrange the incline equation to say WD is equal to GM delta tan theta. Here's the moment that I'd like to know, assuming tangent of 1 degree. Calculate the tangent of 1 degree. You know your displacement, you know your GM. Calculate the moment. Who understands that? Put your hand up. Okay, I need somebody to paraphrase back to me. David, will you paraphrase what I just said here about calculating MH1?
MH1 is a moment to heal 1 degree, or 1 degree angle of list. You would solve the GM equals WD over tan theta for WD, which is the moment. And assume theta is 1 degree. And then find what tan theta at 1 degree is. And multiply that by the GM that we found for this ship model, and multiply by the displacement there.
Correct. And I just want to emphasize that this GM that you use is based on without incline weight. Bear that in mind. You calculate GM with the incline weight, but the only thing we really care about is everything without the incline weight. Good. That covers all. Oh, and then the last one is describe the ASTM. So you all should do a diligent work to read these pages and describe it. Good enough, Spencer. So you all can get working on it.